One of the big issues of our time is climate change, and not so much that climate is changing, but what is causing climate change. And we need to go farther back in time to understand if this climate change is natural or if it's unusual, if it's abrupt, if it's occurring at a rate that doesn't occur naturally. So we're investigating that question using this idea of soil memory. And soil memory in this study has three aspects. And the first aspect is that if you go out and get a soil sample, we have techniques for looking at the carbon isotopes to understand, is the humus, is the organic matter in this soil from grasses that no longer exist, or are they from shrubs that do exist today? And so by looking at the modern soils, what we see is, yes, these soils do remember grasses, but even though they have a memory of grasses, they can't tell us when. It's like they can't remember when this occurred. So the second of the three aspects of soil memory is there a way that we can quantify the time? Can we add chronology? And is there a record? Is there a sedimentary record? Is there a stratigraphic record that we can look at? Well, it ends up that there are two stratigraphic records. One stratigraphic record occurs on a very small scale. Caliche is a term used for calcium carbonate deposits in desert soils. And when the soil gets old enough, it can actually start forming layers of caliche. And but there are various layers that we can dissect. And as we go down deeper, we're going back farther in time. So what we found is that about 1 inch, or even less than an inch, about 3/4 of an inch of this sample covers a time span of about 10,000 years. So this is very important for us to, as a tool, as a method for being able to go back in time using, now we realize, laser level, micron level analysis to understand climate change on a century scale between the current climate and the climate 10, 20, maybe even 30,000 years ago. So that's the second thing that we're looking at, is caliche. The third is to zoom out from the landscape and look at it more broadly. If there's a landscape covered with vegetation, covered with dense grass, it doesn't erode. Even if you have a torrential thunderstorm, it stays in place. But if the grasses, the native grasses, give way to shrubs like we have today, the woody shrubs, the creosote bush, the mesquite, the tar bush, these tend to be, several feet apart, and between is bare ground. So whenever you get a torrential thunderstorm, there's a lot of erosion. And so the soils in the upper sloping positions begin eroding. But this particular landscape has a configuration where the sediment that erodes upslope is deposited downslope a few miles, 2, 3, 4, maybe 5 miles. But the sediment's not carried out of the system like it is in a lot of places where you have big rivers, that carry sediment out. The sediment stays here. So we have a sedimentary record of erosion that took place upslope. So we go out and we dig, backhoe trenches so that we can expose these sediments. And we can see, of course, the modern land surface, but we can see old land surfaces where prehistoric people would have walked and had campfires, where extinct mastodons and mammoths and saber-toothed tigers would have walked on that landscape that's now buried. And so by dating these different layers, we can make inferences about climate changes in the past. And the soil memory approach is being used because that is unique to these desert environments. In more humid regions, there are tree rings that people can core and look at different thicknesses of tree rings that give a record of climate change. But for this desert environment, we're looking at these three aspects of soil memory to help us understand if this climate change is more profound and occurring more rapidly than the natural climate changes of the past. Can human beings, can we actually change the climate of the Earth? Are we now a big enough factor globally that we can actually change the climate? And so that's the big if, and that's the big debate that's occurring today, is you have people saying yes, it's clear, and you have people saying no, it's not clear. And that's why the debate hasn't been resolved, is because it's still evolving.